So this is something that I've been pondering for a while, ever since well, for several years, decades probably, about how robust my original interpretation of the KT boundary radiolarian record was from eastern Marlborough. I've been studying radiolarians from the Paleogene for 30 years, and since doing the study in Marlborough, I haven't found the level of survival in the Paleocene that we see in Marlborough. So it's made me question my original interpretation of a high degree of survival. And so I'm going to talk you through um, some of the arguments now, and yeah, and hopefully have a bit of discussion at the end if we have time. See how we go. This is a shot. This is just reminds me and James probably of some great field trips we had in the glory days of well-funded Cretaceous-Paleogene research at GNS. Big teams going into the Clarence Valley, collecting lots of samples, and this one's coming back from Branch Stream and looking south towards the interesting sections that I think hold some of the answers to this KT boundary survival or not story. So KT boundary, just a quick summary, 66 million years ago, second largest extinction event of all time. 50% to 80% of all life died out, including the non-avian dinosaurs and other stuff. Survivors included small reptiles, birds, mammals, dinoflagellates, diatoms, and apparently radiolarians. But the question I'm pondering now is, did radiolarians really survive? So back in 1997, I wrote, no evidence is found for mass extinction of radiolarians at the Cretaceous tertiary boundary. I did add in eastern Marlborough, so it was the door was open for me to review this to see if it occurred. This lack of extinction was global or just local. And if there were other things going on. So subsequently, we did this major review of early Paleogene biostratigraphy, and after looking at some IODP material or ODP material from the Indian Ocean, I concluded that the early Paleocene assemblages don't include significant numbers of Cretaceous species, calling into the question the contention that radiolarians survived the end-Cretaceous extinction event. Perhaps there's other reasons for the high numbers of Cretaceous species in the Paleocene and eastern Marlborough. So here we are. So just a bit of an outline. What are radiolarians? Review the record from the New Zealand KT boundary sections. Then we're going to do a reassessment of the New Zealand record and bring in some data from other regions, and then look at the evidence for survival. So the idea that I proposed 20, 30 years ago, that the South Pacific acted as a refuge or a refugia for siliceous plankton for some reason, or alternatively that actually all of these wonderful radiolarians that are shown here in the slide, the Cretaceous radiolarians, these are all Cretaceous tax specimens that are found in the Paleocene. Even though they're so nicely preserved, they're actually reworked from the Cretaceous. This, of course, has implications for the KT boundary extinction record. I'm going to probably use KT instead of KPG throughout this talk because I'm old and can't change so quickly anymore. Distal impact of the KPG impact. So if they are reworked, then was the reworking related to the mega tsunami that I talked about previously? Or is it somehow related to things that were going on in the Paleocene in terms of paleogeographic changes? And in particular, I've been exploring the the connections between the Canterbury Basin and the East Coast Basin at this time. Okay. Radiolarians, marine protists with shells of opaline silica, similar in habitat and life cycle as planktonic foraminifera. And that's why it's always been quite puzzling why they might have survived, because the planktonic forams were wiped out, or one species survived. So why would the radiolarians survive when they had a very similar lifestyle? They're different from diatoms, which have, like dinoflagellates, resting spores, resting stages, so they could, a short perturbation, they could survive and come back, but radiolarians don't have that option. They do have a long fossil record. They're great survivors in the geological record overall. Well resolved biostratigraphy through the Mesozoic and Cenozoic, and they're well documented extinctions linked to the Permian Triassic and Triassic Jurassic boundaries. So bit surprising that they weren't affected by the Cretaceous Tertiary boundary event. In general, globally, very few records of radiolarians in the latest Cretaceous and early Paleocene beyond eastern Marlborough, and certainly at the time I did my research in eastern Marlborough, there was nothing really about records from the early Paleocene. In general, though, there are several records of radiolarians being reworked into younger sediments and retaining quite good preservation. So that's always been at the back of my mind, that perhaps this is good preservation. These images that I'm showing you here, all of these Cretaceous species that are found in the Paleocene, apart from this one, which is a Paleocene index species found in the Paleocene, along with these other species, radiolarians. And you can see that the preservation of all of these specimens is pretty similar. Okay. So this is the sections that we studied in eastern Marlborough. All of these sections have really good radiolarian records. I'll just get rid of this little thing here. Yeah, okay. 1, 2, 3, 4, 5, 6, 7, 8 Haiti boundary sections in eastern Marlborough, all in the siliceous Mead Hill Formation, and situated, we think, in sort of off the edge, northeastern edge of Zealandia at this time, in relatively deep water, uppermost bathyal to mid-bathyal setting. And this reconstruction by Miles Ray shows that they form a depth transect from outermost shelf to slope basin, with the deepest one being Mead Stream. Skipping through this introduction. So this is Mead Stream, beautiful section that we were just talking about before. It's been affected a little bit by the 2016 earthquake, and so some of the beautiful outcrops that we have spent a lot of time looking at are not so accessible. KT boundary runs through, there's this dark band that runs through the hillside over here, and you can see it picked out in this picture. KT boundary is actually just here, or just here. This is the KT boundary at Mead Stream. And you can see the dark rock here is chert, so it's a highly siliceous section. In contrast to Woodside Creek, which is not so siliceous, but still full of radiolarians. And so this is the KT boundary. This is now totally covered by the debris from the earthquake, but there is another beautifully exposed section higher up now that doesn't have these drill holes. So those people who were worried about these drill holes from the point of view of geo-vandalism can now be rest assured that they've all been covered up by natural processes. But there's a great new section that I don't think anyone's studied yet further up the hillside, which you can access. Now, so beautiful radiolarians in this section, and these are a mixture, as I mixture of Cretaceous and Paleocene. And the other interesting feature of this section that we first discovered that kind of got us interested in the whole siliceous plankton story was this spike in silica content at the KT boundary. So immediately above the boundary, there's a big increase in silica. You can see it very clearly at Mead Stream with that big chert interval. But at Woodside Creek too, there's an interval of 10 to 15 meters, which is high in silica. And in the microfossil slides that I've made from this section, you see that they're full of both radiolarians and diatoms. In fact, the diatom radiolarian ratio really increases through this interval. And so it got me thinking that whatever happened at the KT boundary might have killed off the calcareous plankton, but it caused the siliceous plankton to thrive for a short period. And this time period is about 1 to 1.5 million years based on this radiolarian biozonation, which we'll talk about a little bit more later. Okay, so this kind of sets the scene for the sections. So 4 primary sites were the focus of my study back in 2003. A series of papers were published representing this transect, proximal distal transect across a sediment-starved carbonate ramp. So not a lot of terrigenous material in these sections. High biogenic silica in the early Paleocene implied an intensification of an upwelling system was the interpretation, and perhaps triggered by climatic cooling potentially linked to the KT boundary, or just coincidental to the KT boundary event. And so this is the Fassi's model that shows the relationship of the more calcareous sections at Flaxbourne River to the more siliceous sections at Mead Stream, and then the link to sections like at Waipa River, potentially. Okay, so no extinctions found at the KT boundary, but there was a big change in the radiolarian assemblage composition, with a big change from Narcillarian to Spermilarian dominance. The abundance of actinomids in particular, and all the Lithomespilus, Amphisphaera, and other actinomids, these are all actinomids that flourish in the early Paleocene. This is the Flaxbourne River section. And coincident with an increase in diatoms and an increase in biogenic silica. So it would seem that this actinomid bloom was also a function of the cooling and the upwelling that followed the KT boundary event. And a rapid appearance of Paleocene species, but although the Cretaceous species decreased in abundance, they were still there. They persisted. So all of these Narcillarian genera that were at the KT boundary, that were in the Cretaceous, continued through into the Paleocene. Okay, so this early work led to a biozonation, which was very useful because it allowed us to start comparing the sections in time rather than in stratigraphy, so we could compare the changes in the different sections over millions of years rather than meters. And this just shows the key markers. So the zonation is based on first appearances of Paleocene species, because there were so many Cretaceous species. Last appearances was problematic. So yeah, zonation was quite useful. So then, looking at the trends in Cretaceous survival across the KT boundary for these, the Marlborough sections, as well as DSTP site 208 on the Lord Howe Rise. And so this is, I guess, the main results of the Cretaceous survival story. This diagram shows trends through time from, it's an old diagram, so it's got the KT boundary at 65 million years, but over a period of, 9 million years. And you can see that we have two colors. So one is the percentage of Cretaceous survivor individuals. So that's just the proportion in the census and in a statistical count. And the other is the percentage of Cretaceous survivor species as a percentage of the total number of species in each sample. And so you can see that in general, the percentage of survivor individuals, the sort of purple color, drops down quite quickly in most of the sections, whereas the number of species declines more gradually. So the species survive, but their relative abundance drops down quite quickly in all of the sections apart from Woodside Creek, and to a lesser extent, Flaxbourne River. But for Mead, for DSCP 208, for Branch Stream, and for Waipara, the proportion of Cretaceous individuals in the Paleocene drops down pretty quickly by within 2 million years of the KT boundary. Overall, though, in terms of species, 69 of the 70 Cretaceous species found in these sections persist into the Paleocene. So essentially 100%, 98.5% survival. Okay. First attempt to explain these differences between these sections was looking at this abundance of actinomids, which, as I said before, seem to be related to an intensification of upwelling. And so it would seem that, let me explain this diagram. So the crosses are the abundance of Amphipindax, which is this species over here. It's a relatively common species in the Cretaceous. It's particularly common at Woodside Creek. Wherever it's common, you have a lot of Cretaceous species in the section. And so you can see that in all of these sections, apart from Woodside Creek, barely registering in the early Paleocene. Branch, Mead, and Flaxbourne, really only at Woodside. And similarly, actinomids, the upwelling indicator, more abundant at these other sections. And so the first hypothesis is that the Cretaceous radiolarians were doing better away from the center of upwelling. And so that's why I came up with this paleogeographic model, which had all of these sections over here and Woodside over here. Like this yellow circle represents the upwelling zone, and Woodside was over to the side. Not very satisfactory, because it's really hard to come up with a way you get upwelling shooting down here and upwelling currents coming in here and not affecting this area. So it didn't really make a lot of sense. But the problem we had, and this is an important part of the story, is that this is the reconstruction. This is the Peter King reconstruction we had at the time. And there was no sense that you would have had possibly a different configuration up here with perhaps water currents circulating through the Canterbury Basin into the East Coast Basin. And we'll come back to that. This just shows the upwelling model, and so the relationship of the sections, they get more siliceous as you get towards the land, and a higher abundance of diatoms. So there's just a model of the sections in general were consistent with this upwelling model. It was first developed by Berger and others back in the 70s. Skipping through all this, sorry, might be a bit fast. Yep, 20 minutes in, that's good. Okay. So the new information, the things that I've learned since doing all that, the first thing is done a lot more biostratigraphy in ODP and IODP material over the last decade or so. In particular, 1403 in the North Atlantic, Indian Ocean sites 752 and U1514. and a couple of sites in the Eastern Pacific, in Ecuador and Colombia. I'm just going to talk about the Ecuador one a little bit. In all these sites, very few Cretaceous survivors in the Paleocene. And the other thing that happened, and this is shown in this picture here, was learning that there was potentially a large tsunami that affected the northeastern side of New Zealand, at the KT boundary, which would have dislodged rock and sediment and potentially reworked material into the basal Paleocene in some New Zealand KT boundary records. And so it was a potential explanation for why there's a high number of Cretaceous tax species in the Paleocene in New Zealand, in Marlborough. And then there was also this work by Ben Andrew, master student of mine from at Waikato University, who was looking at the Paleocene of the eastern Marlborough Kaikoura region, specifically linking the Teredo limestone trying to link the Teredo limestone to the Waipaba formation that's exposed at Mead Stream, and trying to understand what the drivers were for the development of the Waipaba formation. And there was also the GNS work published by Dominic Strogan et al. in 2022 of these new paleogeographic maps. And interestingly, this one, which is very similar to Peter King's map in a lot of ways, still has no connection between the Canterbury Basin and the East Coast Basin, compared with this one, which is the next one up, the Paleocene, has the connection between the East Coast and Canterbury Basins. And I'm going to argue that I think this connection was made in the Cretaceous. I think we have a seaway going between the Canterbury and East Coast Basins in the Cretaceous. And I'll show you the evidence for that now. So this is James's work back in 2003. Did this lovely, with the help of Andy Nicol and Russ Van Dissen and others, Dougal Townsend and Malcolm Laird, figured out that these blocks of eastern Marlborough back in the Cretaceous were configured like this. And so this is a palinspastic map for the Mead Hill Formation. And these are contours for the Mead Hill Formation. And it strikes me, it is very interesting that is when you get to this termination of the Mead Hill Formation, these rocks in Muzzle Stream, Bluff Stream area are macritic limestone. They're not shallow. They're not shallow water deposits. They're bathyal deposits. If you want to get shelfal deposits, you've got to go. This is Phil Maxwell, back in 2005, finding the first record of shells in the Mead Hill Formation. So over here on the Kaikoura Peninsula, we've got shelly Mead Hill Formation. This is shallow over here, but over here, it's deep. And over here, and it's Cretaceous. This is Cretaceous. This is at Muzzle Stream. This is the KT boundary here. These are Cretaceous magritic sediments. And if you go to this spot, haven't been here yet, hoping to get here someday, Pui Pui River. So thanks to the lovely digitized column file that GNS provide, you get, again, macritic Mead Hill Formation in the Cretaceous. And there you go, pure micrite, according to John Morris, verified hopefully by Percy Strong. So just going back, so deep water deposits here, right at the edge of this transition, and I think this must mean that there's deep water all the way going through here. and I would contend that it's probably finding some way to meet up with the Canterbury Basin down here. And this is kind of supported by Ben Andrews' work, where he mapped the Teredo limestone. This is also James's base map, showing that we've got a hard ground through this area here in the early Paleocene, but we've got this big drift deposit forming in the Clarence Reserve area, and this is one of the sections with this big Paleocene green sand deposit, as opposed to the very condensed green sand you get in the hard grounds area like a Muzzle Stream. So this is suggesting that there's strong flow through this area. And it's maybe possible this block is not in the right location, but most likely that this connects to the Canterbury Basin. So I think this is quite important for the story, because it means that we've got a current flow that's traveling from south to north and eroding what would have been Cretaceous Mead Hill Formation in this area and depositing it in this area, which is where Woodside Creek is. That's why I went on that ramble. Okay. So, reanalysis of the radiolarian survival record. Yep. I'm going to focus on narsilarians, which are these guys up here, because they're easier to assign names to. Spermilarians are tricky things, and it's harder to be sure that to distinguish between Cretaceous and Paleocene species. So narsilarians are more straightforward. We'll work with them. And also narsilarians dominate all the Pacific Cretaceous assemblages studied. So they're a good guide to what's happening across the KT boundary. Radiolarians are typically rare and poorly preserved in latest Cretaceous sites from other regions, but we have got quite good Paleocene records. The Paleocene radiolarians at the sites that I'm going to show you, 1514 and 752, are well preserved. So I'm telling you that to assure you that if there were Cretaceous radiolarians in these sites, we'd see them, even though in the Paleocene, even though there's not a very good record of Cretaceous radiolarians directly below in this region. 10 sites. Biostratigraphy, so applied the same zonations that were developed in Marlborough to all of these sites. And this is 1514, and you can see that there's a really good Paleocene record going from the base of the Paleocene all the way up. This is the age model with no obvious breaks. And the green radiolarian bio-events, so rads all the way through these sections. So this is one of my you're going to see a few messy graphs, I'm afraid. I'll pretty them up for publication, but just for this talk, you guys can cope with this, I'm sure. This is Cretaceous narsilarian occurrence in the Paleocene. So this is just simply numbers of Cretaceous species for all the sites that I've got good data for. 1403 isn't shown here because there's no Cretaceous species, so there's nothing to show. But you can see that Woodside and Flaxbourne are showing kind of what the other graphs I showed, that there's reasonable numbers of Cretaceous species in the Paleocene. They dive down about here for Flaxbourne and about here for Woodside, but they're still quite high. So this is numbers of species, 35 is the maximum, or 34, and they drop down to about 20 for Woodside by 61.5 million years ago. Pretty gradual decline. In contrast, for mead stream and branch stream, they stay high in this interval here in the grey zone, but then they drop down rapidly. And the grey zone corresponds to the high silica interval, which I think is quite important. So in fact, all of these sections have quite high survival, high numbers of Cretaceous species in this interval with high silica. This is percent excess silica. We also see interesting, the Via Perimetral section in Ecuador shows a massive drop right at the KT boundary, but then a resurgence and then drop down again. And this is a pretty not sure what overall silica is doing in this section. We didn't do that geochemistry, but this is a good candidate for reworked Cretaceous material because it's such a spike and then it recovers, it drops down pretty quickly. These ones are less straightforward for interpretation. And then for 1514 and 752, few Cretaceous species in the Cretaceous, and they stay low all the way through. There's hardly any Cretaceous species. And in fact, all of the Cretaceous species that are in here are these ones, which are what I call the true survivors. So these are things that you find in many Paleocene and early Eocene radiolarian samples from around the world. Bathropyramus and Cornutella, deep dwellers that have a long geological record and don't change very much. Differentiating between the Cretaceous species from Paleocene species is pretty difficult, but there's really no apparent obvious difference between these species. They seem to continue. And the same with Amphiturnus and Meta and Cyphocampi. They're all things that occur in the Cretaceous and occur pretty frequently through the Paleocene and Eocene. True survivors. In Ecuador, it's an interesting story that I haven't got time to go into all the gory details, but this was a project I did with Gerta Keller, and we had a bit of a disagreement about where the KT boundary was. She thought it was down here. I was pretty confident it was up here. So we agreed to disagree, and we put two KT boundaries in this section. Now that I'm looking at it again, she might be right, because if she is, then these are all reworked radiolarians, because there's no way that this is a clear increase of spermolarians that we see everywhere with the KT boundary, and here we see this some survivor Cretaceous species in the Paleocene, but they quickly decline and disappear. So if I think Ecuador is an example where if there are Cretaceous species in the Paleocene, then it's almost all due to reworking. And it's not surprising when you consider that this is really close to the impact site, and so there's likely to be a fair amount of disturbance of Cretaceous material. Anyway, you don't want to dwell on Ecuador; it's complicated. This is a pretty interesting figure. I like this figure. This is showing just the percentage of Paleocene samples that have Cretaceous species in them. So it's the Cretaceous-Nassilian persistence figure, and it's ordered in this case based on Woodside Creek. So this is the most abundant species at Woodside Creek going down, and you can see that Woodside Creek has much higher level of persistence than all the other sections. All the sections have Amphipindax and Dictyomitra as the most persistent species. You can see them over here in the other sections. But none of them show the same level of persistence that we see at Woodside. And there's some really interesting highs for Site 208. So some species are really abundant, really persistent at site 208. So what I did next was I reordered this for the flax spawn section rather than Woodside, because you can see that the dominants at flax spawn at all the other sections are over are the dominant species are over here. So if we reorder based on flax spawn, we get this figure, which I think is fascinating. So what we see here is, again, much more jerky because it's ordered by flax spawn. This is flax spawn going through here. So Woodside's all over the place, but all the others show a pretty clear trend, or flax spawn, mead, and branch all show a decline in persistence that shows pretty orderly. The same species are dropping out or less persistent till you get to low persistence down here. And some of the species that are present at Woodside Creek just don't occur in the Paleocene at these sections. So this suggests to me that something different is happening at Woodside than at the other sections. And it also suggests to me that, given the spikiness of the DSTP 208 record, that something different is happening there. What that difference might be: different environmental setting, better preservation, possibly. It is really well, the radiolarians are really well preserved at Woodside, or persistent reworking of the Cretaceous taxa at Woodside Creek, and possibly also Site 208. Okay, so this is getting to the crux now. This is a nice study that Epsom Moran did back in the 1980s, where she was looking at Campanian radiolarians, and many of these species were around in the Campanian, so it's applicable to this story. She found that there was a depth differentiation for Narcillarians, or for radiolarians in general, with these guys, Amphipindax and Dictyomitra, most abundant in neritic waters. Unfortunately, she only had one neritic sample, so it's not necessarily that representative, but certainly these taxa were the dominant ones in that sample from Texas. And then as you go into deeper water, you get these guys over here: Milicercion, Theocampi, and Sticomitra. And so that's pretty interesting, because Amphipindax and Dictyomitra are the ones that dominate the Cretaceous assemblages at Woodside Creek, whereas these guys dominate the assemblages in the other sections. I can show you this. So this is comparing flax spawn and Woodside, and just looking at the trends in the dominant genera. And this also isn't that flash a figure, I'm afraid, but it's a cumulative percent. So Theocampi on this side, Theocampi plus Sticomitra, those two plus Milicercion plus Dictyomitra plus Amphipindax, and the same on this side. And so what you see is, for Woodside Creek, this Dictyomitra Amphipindax complex is largely dominant in the Cretaceous and in the Paleocene, apart from perhaps this interval in the earliest Paleocene. At flax spawn, it's also dominant in the upper part of this section. But otherwise, you've got an interval of Theocampi mixed taxa, one sample at Woodside Creek, most of the samples at Flax Spawn River, and then through this basal Paleocene interval at Flax Spawn River. This Theocampi mixed assemblage is also dominant at Branch and Mead Stream. And so what I'm angling towards is suggesting that this is the in situ assemblage for Woodside Creek, this is the in situ assemblage for Flaxbourne River, branch stream, Mead stream. This is potentially an in situ assemblage too, because there's no changes, particularly in the makeup of the Cretaceous taxa in the Cretaceous and in the Paleocene. But this one is different. And so I suggest that when you get up here, both at Woodside and at Flaxbourne, you're bringing in a reworked neritic assemblage from somewhere else. We'll come back to that. So the other thing about these two sections, which is quite interesting, is I've started this whole investigation because I was looking for evidence for tsunami debris, some evidence of tsunami reworked Cretaceous material in the Paleocene, indicating the evidence of the impact of a major tsunami on the New Zealand coast. And so looking at Woodside and Flaxbourne, there is this little interval. This is just, yeah. So the orange curves here is parts per million of nickel. And nickel is in these sections is a nice proxy for iridium when you don't have the capacity to do iridium analysis. You can do nickel very easily with XRF, works pretty well. And so there's a nice nickel spike at the KT boundary for Woodside Creek. And there's repeated nickel spikes at Flaxbourne River. And that's what we found, or Robert Brooks found with the iridium too. There were multiple spikes in this early Paleocene interval, probably due to reworking. And so associated with these nickel spikes are these increases in abundance of Cretaceous taxa. Here and possibly here and all through here, maybe up to here. And so I would argue that this is potentially, if we did get a major tsunami, then perhaps these Cretaceous taxa in the base of the Paleocene in these two sections are evidence of that tsunami reworking Cretaceous material into the Paleocene. But there is another explanation needed for the Cretaceous taxa higher up. There's no increase in nickel. It's not tsunami up here. So that brings us to close to the conclusion. So refuge or refuse. And refuge, this interval directly above the KT boundary when things get cool. This is the Tex 86 record from mid-Waipara showing massive cooling signal, dramatic cooling in the early Paleocene, and unconformity right here at the base, just in the early Paleocene. Linked to silica bloom is an interval where we get that that mixed assemblage, that mixed radiolarian assemblage that still, I think, may actually be Cretaceous survivors, true Cretaceous survivors, thriving in that upwelling system of eastern Marlborough. So I think there's a case for this region becoming being a refugia for siliceous plankton in the earliest Paleocene. And I think this links to this discovery of Ben Andrews largely, that there was probably a current flowing through this area, eroding off the Cretaceous Mead Hill Formation and depositing it through here and causing, we'll come to that bit later, and also causing upwelling in this area, intensifying this kind of upwelling model. Okay, and so that's the Theocampi assemblage that explains the earliest Paleocene. And then Ben's story would be this current coming through from the south, eroding this part of the Mead Hill Formation and depositing parts of it up here in the through the early Paleocene till about potentially, well, 61.5 million years ago. Yeah. Cretaceous radiolarians redeposited in Paleocene sediments throughout the subbasin for 1.5 million years, and restricted eastern area over here for a further 3 million years. So this assemblage, the Amphiponax dominated assemblage, is potentially the one that's been redeposited, and is the one that is associated with a large level of apparent survival in the Woodside Creek section. So, and this would explain what's happening in Marlborough, and perhaps 208, where you see a similar pattern to Woodside Creek, not quite as extreme. Perhaps it's also reworking from Cretaceous exposed sediments into the deeper basin around site 208. So possibly an intensification of current flow around this region, reworking radiolarians. So in summary then, this research poses some fundamental questions about the nature of the KPG extinction event, the regional impact of the KPG event, and the evolution of eastern sedimentary basins. Many outstanding issues to resolve. The big one is not a great record of other types of fossils being reworked into the Paleocene. It may be that the upwelling conditions were not conducive to preservation of calcareous fossils, so perhaps the forams and nanos were dissolved. Maybe there were no significant numbers of dinos to begin with. We know that dinoflagellates were, Cretaceous dinoflagellates were present in the earliest Paleocene, but we're not sure that they were reworked or not. Manumiella, the Manumiella assemblage. Fossil content of this area over here, we don't know anything about it. No one's done this work. And this whole evolution of the East Coast Basin, Canterbury Basin connection, haven't really done sufficient work there. We need to do further analysis of this quite rich survivor assemblage to try and understand more about the environments that are represented by those species. And we also need to get a better handle on the whole climate record through the KT boundary transition. The problem with that mid-Waipara record is it's whopping great unconformity just when you have that lovely cooling event. I think some answers might lie in this area. I think this would be a great area, Catherine, for some field work, or James, if you have any ideas. And to conclude, Cretaceous radiolarians in the Paleocene and Mead Hill Formation reflect local ocean conditions following a global catastrophe, the far-reaching effects of the KT boundary mega tsunami, strong current flow between Canterbury and East Coast basins during the Paleocene. I reckon that's probably about enough. And I would like to acknowledge this work was originally funded by Genius Science. Genius Science continues to provide great resource in the form of the fantastic fossil record file and the column file and many other online resources that are available. So good to have those resources, and also thanks to IADP for access to the IADP material. Thank you very much.